Okay, welcome back to the Statosphere chamber. I'm John Rowland, and I'm one of the stewards, and I tend to look after lots of kits within this place, and as a result of that one learns an awful lot about the place. So today's video is going to be about the electrical system, and if you've seen my previous video underneath the door, then at the very end of that I refer to the spiral staircase, which you can see here, as you go up to the top of the spiral staircase, you will see that it talks about an electrical substation, and there's a sign right at the top that says number 8 substation. And when we go inside in a minute, you will find out a little bit more about what that is all about. So this was one of the 8 substations. So the other substations were all around the site at Brooklands and Vickers as they were. And that basically they were all interconnected with a very large ring main, apparently, and so that they could all support each other. And my understanding is that there was also, at a later date, they had some Avon engines which supplied generators, which allowed them to so they could take peak power and generate it themselves. Okay, so as we enter this substation, then we are full of ancient pieces of kit, which, as I say, were all installed, apart from a few new items which came into later with the museum, back in the 1950s. So the equipment here covered more than just the Statosphere chamber, although the Statosphere chamber must have been a very significant load that was supplied from here, based on the, shall we say, the large amounts of motors and other machinery out there. Now, as we look at what we have on either side here, we have what are known as oil-filled circuit breakers, or OCBs, and they've all been relabelled since the days when it was 1950s, when it was part of the Statosphere chamber. So the Discovery is the room below here, and Concorde has been fed again off here, and the other side of the Statosphere chamber gets fed off another one there. Now, the interesting point, of course, is that these are basically 70 years old and they are still going. And you can actually see on this particular that there's a small reading on there which shows we are drawing current from there. The peak for these particular items, I believe, is about 400 amps, although the meters show up to 500. But I think they would cut out at around 400. Let's have a quick look. Yes, ratios. So there we go, amps 400 on this side, it actually shows you. So that's basically giving you the amperage that it'll caper of, the voltage, which is 3-phase, and the frequency at which it'll operate. And most of them are the same, although there's one particularly special one, which we'll come to in a second over here. Now, these ones here are not are not connected, I believe, or even though this one appears to be actually reading slightly, but excuse me. But the one to the left immediately here is a slightly unusual one, and it's still got its sign on there, and it says the Ward-Leonard set brackets fans. So the key about the Ward-Leonard set is that basically that was the system that allowed the the 3-phase AC to be converted into DC, which is how the fans, or the 4 fans that we have in the ducts, which you may have seen on other videos, are fed. You have to feed them DC because back in the 50s, if you wanted to control the speed, you couldn't do that with AC, because these days we chop the frequencies up, so you can actually have variable speed on an AC through a 3-phase motor, but in those days you couldn't do that. So you basically took a DC motor and you've changed the field coils in there in terms of the rating, the current through them, and that would actually change the speed of the motor. Now, the motor speed is controlled from the control room that we have seen in another video, and if you haven't seen that, you may like to have a look at that. But to generate the DC, you have what's known here as Ward-Leonard set, and that's why it says fans, because it basically fed the fans. But of note, of course, is that this particular OCB read up to 1500 amps, and the plate rating here gives you 1200. So that basically gave you 1200 amps of three-phase to feed effectively two Ward-Leonard sets. Now a Ward-Leonard set is a motor, and on each end of the motor they attach two alternators. Now in the cars, you may know for cars, the alternator generates your DC. What the alternator actually does is create a lower voltage AC, and depending on the wiring, depends on the frequency you get out of that. Put that through a rectifier, and downstairs, in the Lucy room, which is immediately below us here, where the Ward-Leonard sets were, there was also a massive great rectifier stack, apparently. So that would then turn it into effectively DC, because it would sum everything together, so you have a DC voltage with quite a big ripple on the top of it. Now, as I said, they had two of these sets for providing the DC, mainly no doubt due to the fact that it had four basically DC motors out there, all of which are quite power hungry. So as we move through here to my left, that will be coming into view shortly, there we go, we have what's known here as which calls itself an electrodynamic construction. Now, and as you may be able to see on other parts of this, you have these two labels called number 1 motor and number 2 motor. Now, this is the two different motors that are driving the generators, or the alternators, should I say. Now, it appears, and I'm not entirely sure how that worked, but you had what was a low and a high frequency. So I'm assuming that the two alternators on the ends of the motors actually generated a different frequency. They were probably wound differently. It could well have been done that way to allow for the ripple to be made less on the DC. Now, what you then had to do is you have basically two sources of DC coming off, and they have got quite significant ripple on them. So you need to be able to tie these two together so you can actually power or provide more DC power. Now, to do that, you have to synchronize the two outputs, or else if you were to effectively join the two together when they're out of phase, you would get a very large bang, flash, and the whole lot would stop working because of the very large current that would occur. So that is what we're seeing here, and this control panel is a means of being able to synchronize the equipment. And basically, from what I can work out, this was the number 1 set, and on the right over here is the number 2 set. Hence, it talks about their number 2 motor alternator, and on this other side, number 1 alternator. And as you can see, in the middle, it has a synchroscope. Now, this basically has connections to each of the alternator sets, and it will give you an indication of how close to synchronism they actually are. And you have a number of ways of trying to alter or change the frequency, which has a number of these different dials, shall we say, on the front. These days they'll be a lot smaller, and the fact it's talking about raise and lower, I believe that's to do with the type of kit that they have downstairs, which is actually slows or speeds up the AC motor, three-phase motor. Now, the other interesting feature you have here are the 3 bulbs, and it says synchronizing and paralleling. So what that is basically, you have each of the bulb is connected to one part of phase of each side. So from what I can tell, 2 of the bulbs, one will be fed from what they called low frequency, and the other one will be fed from what they called the high frequency side. Now, if they're out of sync, basically these bulbs will be flashing. They'll be flashing together. Now, as you start adjusting the speed, then the bulbs will start flashing at a slower rate, and when you've actually got them properly in sync, then the bulbs should go out, because you can detect much better whether the bulb is glowing at all or not. So when it gets to the point where the bulbs are apparently all off, or potentially 2 of them, maybe all 3, I'm not quite clear how it was wired, you are then in a position you can actually synchronize, connect together both of the synchronized pieces of kit. And then you can actually, they'll run off each other, so one will drive the other should more power being applied to one of the kit's sets or of the Ward Leonard sets or the other one. Now, the other interesting, none of this stuff is live, fortunately. There we go. So in here, you have what I always call an Igor switch. So basically you have a locked off three-phase switch which you will be able to pull across and connect together. Now that, I'm not entirely sure whether that is how they did, was the synchronizing element, or whether that's all part of the basically circuit breakers and relays that go below. I suspect it actually was connected via a relay, because the Igor switch, as I call it, talks about motors and separate load, so I imagine that was actually connecting the motors rather than actually connecting the outputs. But what you can see in here is a whole load of 1950s, basically large, basically contactors. I won't touch any of that for other reasons other than there's no electrics, mind you. But then you have all the fuses all lined up down here, and on the door we have all the spares. And you can see that's a relatively large fuse. I'm not quite sure if it's got a rating that I can read off it, but it's probably several hundred amps, I suspect, that particular fuse. There are a few bigger ones around the place, but that's, in terms of this kit, that appears to be the maximum, shall we say. Okay, so on the other side here, and this is actually still live, this is actually what drives the whole of the Brooklands area in terms of the museum. And there's the new, basically, install, which was done, I assume, in the 90s, but the actual transformer on here, which is outside, down below, is a 315 kVA, kilovolt amp, and basically all this lot is still all live. So this is why you don't touch it, and indeed you can see it says on that particular large contactor. And if something went wrong, it would make a big bang. But basically, say this is still all used. The other side isn't required anymore. And in its day, as you may see, this is actually in an off position. In its day, number one incoming was 500 kVA. Now, I believe there were two transformers that drove each side, and I think they were both 500 kVA, although one might have been slightly more than that, I'm not sure. But, so this is basically, I say, the kit from the 1950s, which is no longer used. However, the bridge over our heads here still carries the live cables to the oil-filled circuit breakers that we saw on the way in. Because the outputs basically out to the chamber itself are on the wall to my left over here. So that's all been installed in the 90s and updated and upgraded as we go. So when the place was in operation, as we've mentioned before, the control room was where experiments were basically controlled from. And they had to have the ability to be able to communicate with the substation before they before the kit was started up. The actual plant was controlled from a room on the opposite side of the chamber in the corner, and basically the control room could talk to them, I believe, using effectively a telephone system using headphones. Now, to here, there is an alternate system which we can see on the wall, which has been there since 1950s, which is another one of these dial-up telephones. So basically you crank the handle, which generates a voltage, which means the other end will ring, and when you pick it up, basically you don't need power to run it, it's a self-powered telephone. Now that, I'm assuming, is the way that they generally communicated within here. So now, apart from the motors and generators below, it will be quite quiet in here, so the generators probably make quite a racket, but there's a pretty solid floor here, so I imagine you could hear the telephone ring quite well, so you could then answer the phone to be able to from someone from the plant saying, "Oi, Fred, turn it on, please," at which point he could turn on the necessary kit to be able to provide the voltage for the plant. Okay, so that is basically what we have here, and as you say, it's all 1950s apart from the brand new pieces of kit. And the boxes here, I believe, are the terminations that came up from the original transformers, which are right below us here. And as you can see, that they've generally been cut off. I'm never quite sure why this one had basically its wires were connected, because normally they would be connected into a box like this one. And there are 4, I think, or is it only 3? There are 4 of them, yes. There are 4 basically connection points here. Now, what I don't quite understand is that we have the big doors, which you would have thought would be a way of getting things in and out. But there's no hoist on it. There's just a set of stairs and an emergency exit door at the moment. So, and I can see no evidence that there was a hoist in here before. So I'm not entirely sure how they got all the very big and heavy stuff in here. Okay, so as we said, basically if we look behind the cabinet here, you can see where all the power goes out. So this all goes down into what we call the Lucy room, which is a workshop now. And if we go outside now and down, we can see where all the power was originally routed, because it's all properly marked up to enable people to be able to maintain this sort of kit. So with a quick last look at the kit there, I think we should now proceed and go down the spiral stairs, and we can have a quick chat about how the power was then routed and some of the other unusual features that we have around the place. Okay, so now that we're at the bottom of the spiral stairs, we can see where originally all the cabling used to run. The door here runs through into the area which we refer to as the Lucy room. I'm not entirely sure why. But as it says here, it's got 11,000 volts authorised personnel, and even here it's got British Aircraft Corporation. So you could see it was all running through those years, and I'm assuming that would have been 1980 whatever, when the place was being closed down. It has just been left. So we can't go through there particularly, but there's nothing of particular interest in there. As I say, it's now a workshop. But if we look at the floor here, although things have been to some extent replaced, then basically all the cabling that came down would have gone through these trenches. Now we know that because here is the original cover for the trench, and it's red. So electrical cables were always put in trenches that have a red cover. So as we go round the place, we can trace where all the electrics were by the fact that we have these red coloured tops. If we come through the no authorised entry gate, for whatever reason they decided to put a kink in the lane, but underneath there would have been, I'm sure, 4 or 5, given the number of OCBs we had up there, large cables. Now the type of cable probably is like to the one we can see here. So that is a very large 3-phase cable, and it's wrapped in cloth at the outside, and inside would be bitumen, and there was armoured basically steel cable sort of, which just gets wrapped around it, and which is why it's quite so stiff as it is. Now, while we're talking about this particular cable, you might wonder, and indeed I have wondered, why this cable is lying here whereas it's not in the trench. Because if it was put in at the time when everything was being assembled here in terms of the plant, it would have gone into one of these trenches, and given it probably had another trench running over there. Now, I believe the answer to that quandary is the fact that this cable here is running across to a green cabinet you can see in the distance. Now that green cabinet is the control for the heating system that's underneath the chamber. So in the introduction, I believe it was stated that you could warm the temperature up in the chamber up to 40 to 55 Celsius. So that's getting quite warm. And to do that, there's a whole load of heater blocks underneath, which we did have a look at when we had the little video I did under the chamber, which if you haven't seen, please go and have a look at. Anyhow, to the best of my knowledge, the heating system came in after effect. So this was after 1952 when the chamber was put into use. And I believe that is supported because that green cabinet, I can't see it on certain of the early photographs. At least I believe I can't see it, because it is obscured slightly by that tower, but I cannot see a blocks behind it. The fact it was green, it may well have been silver originally, and it got overpainted in green. I know it was overpainted because they overpainted everything on there, and I had to chip it all off a few years ago so we could see the labels on there. So if we have a quick look at that, we call potential interest. To do that, we have to negotiate a few things to prevent people normally getting through here. Now, as one can see, the cable runs along here. It then has a 90 degrees shift, and indeed you can see the armour on the outside there, which is the steel bands. I'm not entirely sure why it has quite such a sophisticated right angle on there, but it obviously does the job. But if we can, he says, got it, undo the door, you can actually see inside here another set of quite large fuses, and these I believe are 100 amp fuses. It says S100, English Electric. You then have relays for controlling things, and there's the large inlet safety valve, switch, and these are the input three-phase coming in, hence the three cables. And there would be somewhere be an earth, but I'm not quite sure where that comes from. But as you can see, this board, which is mainly just a few relays, contactors and the fuses, is then connected to the front panel, which you can see here. And what we can then see is the controls for all of the individual heater banks. There is a cooling fan motor, which I assume was to cool the fan under there, otherwise it probably would get very hot. But here we have the heater banks, of which there are effectively 5, and some of which are still labelled, whereas others aren't quite so well labelled. But here we've got you got 37, but there was a larger bank which was more or less double that, which I believe was 75. But in total, we reckon there was about 200 kVA, basically, oh sorry, kilowatts as it says here, in terms of heating. Now, you may have noticed I nearly said kVA. When you're measuring basically power on an AC system, you would measure it as being kilovolt amps. So that's volts times amps normally equals watts. But in an AC environment, you're not quite sure what the power factor is. So you may not get all of the power you're putting in coming out as useful energy. Now here, these are the ratings of the heaters, so that's actually what the heaters would generate in actual watts. Now, how much kVA we put in would probably be greater than that, depending on the power factor, as I say. Now, we always try to get a 0 power factor, but very rarely achieve that on anything that's inductive. So anyway, upstairs you may have noted it refers to kVA, which is the nearest thing we have as effectively to power. Whereas here it does actually then talk about watts, because that's actually the heating system underneath. Okay, so if we quickly shut that so it doesn't fall open, you may notice that here on the floor we have another piece of red. So there you can, this red here is the main power connection, and you can see many of the power cables up here coming through. Now some of these relate to the motors above, but I believe these are terminations also for the power, which then gets connected on through to the other side where it goes to the plant control room. Now the cable or the main power feed would have come across through to the plant control room, and then basically there will be a set of cables coming back, and if we look at the floor in the middle here, you may see that actually it's got 2 angles on it, and I suspect that is because you had main power coming in and then be coming round and given that how tight these cables are, you can't put small bends on them, so it'll have a large bend going through, and then the cables coming back, which were powering the plant in here, be coming back through here, and one of them went straight on there, but the others would come through here. So there is a connection there which would have been for the other of the compressor units, of which we have 2 of the 4. And as we come through here, the next outlet is for this compressor, which is still here, and you can see the cables coming out of the floor, and they will come to the unit, or the square box you can see here, which actually is the motor starter system. Basically the little black dial knob there, basically you rotate that, and there are sort of forks that come together inside the box, and as they come together, it provides a lower, the voltage is increased by winding that through onto the motor, which is the device behind. And there must have been some form of starter, and I'm wondering whether that's the little lever there is used for starting. So you have to, being an AC motor, you have to basically get the field rotating at a slower pace to get the thing to start up until it becomes, well, the squirrel motor will then run at its full rate from that point on. Now, the red trough continues down here, and we have the next of the compressors, and it disappears into what's now the education area where the other compressor would have been. Now, in the far distance also, we had the vacuum pumps, and we passed that slightly earlier as we came down the corridor here, because the pumps were in the corner, originally 1, but then they were expanded to have 3, and we have examples of those here. So these would have been then fed from cables running on the continuation of the red trough, which is leading underneath the education centre. Indeed, if we could get into, and it's not really possible, there's a store area basically just as we come into in the lobby there, which is on our right. There's a door, and if you go into there, you can actually see the marks in the floor where one of these type of vacuum pumps, the sort of low type, would have been sited, and you can still see the cables coming out of the floor, and certainly the pipework above that's still in there, which was not removed when they turned it into basically a store area. Okay, so now we're on the other side of the chamber from where we were before. We had the other motors and so on, and the cables we saw disappearing underground. And those cables basically come out on this side, and the DC connections to the motor go up this tower, and you can see some of the cables kind of hidden a bit behind the girders there. But basically that's where the DC cables would have come around from the other side. But also here we have the connections that would have gone through to the plant control. We have some new cables that have been put in here, but there's a stub pointing through the wall, so that is an old piece of cable. So you can see again how it's wrapped in a sort of tar and pitch there. But as we come across here, then the cables ran across here through into the plant control room. Now, you might be saying to yourself, but that's not coloured red. But the giveaway here is we've got the red tiles. So there's a red tile at that end, and also there's a red tile at this end, which is slightly hidden underneath the mat and the other bits and pieces, but we can see it there. So that again was a connection basically for the electrics. And that's what went through into the plant, and in the plant control room, that's how they would turn the power on and off to all the relevant pieces of plant in terms of compressors and vacuum pumps and so on. So they controlled the power, and then basically people on the far side would have turned the bits of kit on and using the devices that we saw over there. And the fine control ultimately be done from what we call the control room, where they would have fine control, or they would communicate basically with the people in the plant room and in the plant area to actually stabilize the equipment when you get to the point where your pressure was at the right level, and indeed when the temperature had come down to the right level, and they would then balance it all off, and that would have been done within the plant room itself. And to do that, they basically would communicate using headsets. And we have here on the frame over here, we actually have one of the original headset connections which has survived. So that basically is a headset jack. So you can plug yourself into that, and then you would be able to talk to the people in the control room, or more importantly, people in the control room could talk to you. And as we have seen before, this particular telephone, this is not in a given position, it's on display here, but my assumption is that that probably was in the plant control room, and as we saw in the electrical room, substation, there was a different type of wind-up telephone, if that's the way of looking at it, which basically would be able to communicate with this. And in this case, basically, you have a similar system that you could actually indicate to the other end and then lift the headset, given that we don't allow that to happen, and then talk basically using the, being a non-electrically connected, but it's a volt-free headset system. Okay, so that gives you an overview, shall we say, of the electrics as used to be in the chamber in the 1950s. And as I say, things got modified as we move on. So we had the heating system got put in later, we believe. And so basically that all happened during the 50s and was all running through to the early 1980s. And I don't believe there was any major changes took place during that period of time. So all that kit that we saw in the substation would have been operating for up to 30 odd years, and no known historical evidence anything went drastically wrong. And since then it's been part mothballed and is now being used, the same pieces of kit being used to supply electricity around the Brooklands Museum site.